So now let's go into the detail of the traceback mechanism. The main component is the edge sampling algorithm. An edge includes the start and end IP addresses. It also includes distance, which is the number of hops since the last edge stored. Here's the procedure for a router to decide how to record the edge information. When a packet arrives, it tosses a coin. If it's head, then it will write its address into the start address, and then write 0 into the distance field. If it's tail, then if distance is 0, then it writes its IP address into the end address field. And regardless, it will increment the distance field. So here's an example. Again, a packet would include edge information, which includes the start address, end address, and distance. Suppose the packet travels through 3 routers, R1, R2, and R3. R1 tosses a coin and its head, so R1 writes its address to the start field and 0 in distance. Now R2, it tosses a coin and its tail. The distance was 0, so according to the process, it should write itself to the end and then increment distance to 1. Now for R3, it tosses the coin and its tail again, but the distance was not 0, so it does not write itself to the end. It simply increments the distance. Now it's 2. Now for R3, it tosses the coin, its tail again, and the distance is greater than 0, so it does not write itself to the end. It simply increments the distance from 1 to 2. Now as you can see, the edge information includes the starting of the edge, which is R1, the end, which is R2, the distance is 2. That means from R3's perspective, the distance is 2 since the beginning of the edge. With the edge information, now we can talk about how do we reconstruct the path. The packet arrived at the victim contains edge information, and this information can be extracted to reconstruct the path that started from the victim all the way to the source of the attack packets. Again, the edge information contains the starting router and the end router of the edge and the distance from the starting router, and the number of packets needed to reconstruct the path is given by this formula. This is the expected number of packets, and P is the probability of head versus tail, and D is the length of the path.